Question 4. Hope you already had a look at this question already, so I'm just going to go straight into it. Investigate at the 5% level of significance whether the mean amount of sugar purchased per person in England has changed between 2014 and 2018. Two things to note here. It says here that it's changed between 2014 and 2018. So it's not increased, we're not talking about decreasing as our claim, we're talking about changed. This means it's a two-tailed test, which is going to affect our significance level. So we need to halve the significance level because it's a two-tailed test. What that means is we're splitting up that significance level into 2.5% at the upper tail and 2.5% at the lower tail. So rejecting, or in our critical region, we've got the top 2.5% values. In our critical region, we've got the bottom 2.5% of values. So this is our hypothesis test. So we start off with our null and alternative hypotheses. So it's normal distribution, so we use mu now. With binomial, we'll use p. With product moment, we'll use rho. With normal, we use mu. The null hypothesis is that the mean is unchanged at 78.9. The alternative hypothesis is that the mean is not 78.9. Okay, so because it's a two-tailed test, we put does not equal 78.9. When we're doing this for normal distribution, we're looking at a sample. So that's why I need to put x with the line above it to indicate that I'm looking at my sample. So the mean is going to be 78.9, what the mean claims to be. And the variance is 25 squared. In the question, you're given the standard deviation. So the variance would be 25 squared. But the sample variance, I need to divide it by the number in my sample. So I need to divide that by 918. So be very careful there. The sample variance is 25 squared over 918. What this means is the sample standard deviation is going to be 25 divided by the square root of 918. Okay, so just squaring 25 squared over 918, I get 25 over square root of 918. So in the sample, it was found that 918 people had a mean of 80.4 grams of sugar purchased per person. So 80.4 is above the mean, so this means I need to test it in the upper tail. So what I need to do is work out the probability that x is greater than 80.4. A lot of people made the mistake when they did the test of putting less than, okay? Because 80.4 is above the mean, it's going to be greater than here. If I was looking at a number that was below the mean, then I'll put less than. So we work this out on the calculator. So I go menu, 7, and then normal CD. My lower limit is going to be 80.4. My upper limit, just put in a big number, such as 100,000. Standard deviation, remember this is 25 divided by the square root of 918. Okay, the population standard deviation is 25, but for the sample I need to divide it by the square root of n, so divide it by square root of 918, and my mean is 78.9. I'm going to do that to three significant figures. Remember, please put three significant figures. I get 0.0345. This is greater than 0.025, okay? Half my significance level. So it's greater than half the significance level. So because this probability is greater than 2.5, it's greater than the significance level for the upper tail. What that means is I accept H0. Whilst it's showing that it's reasonably unlikely that I get 80.4 or more, it's still greater than 2.5%. So I accept H0 and then make my conclusion that there is insufficient evidence to suggest the mean amount of sugar purchased has changed. Okay, and that's what I need to do for all 6 marks. Let me know if you have any questions about that, and then we'll just finally, before I end this, go on to part B. Part B states another test is performed to determine whether the mean amount of milk purchased per person has changed between 2014 and 2018. At the 10% significance level, the null hypothesis is rejected. With reference to the 10% significance level, explain why it's not necessarily true that there has been a change. So just because we reject the null hypothesis doesn't mean that there was actually a change, okay? What we have to bear in mind with a hypothesis test is we're never 100% accurate, okay? We're never 100% accurate. So what I would need to state is just really understanding what the significance level is. The significance level is the probability that I'm wrong to reject the null hypothesis. So all I would need to write for this question is state there is a 10% chance of incorrectly rejecting the null hypothesis. Okay, so that's what a 10% significance level means. If you had a 2% significance level, that would mean there is a 2% chance of incorrectly rejecting the null hypothesis. So that's all you really need to put for that part B. So let me know if you've got any questions about that. That question in particular, part B, was answered quite poorly. I think it's just getting the idea of what a significance level actually is. When we do that hypothesis test, it could just be that in our particular sample we picked, we just so happened to pick one that had a number, a value that was far greater than the mean. So just bear that in mind when you do a hypothesis test. It's not always 100% accurate.